Hey, what's up? My name is Greg, and today we're going to build a code-gen agent or workflow using O3 Mini and RZA. I'll show you what this will look like when we're all done, and then I'll show you how we built it. So we're going to run this file called holdem.py. We just defined the requirements for our script. We want it to simulate a game of Texas Holdem, and then I use code-gen, write, review, and run code. And when I do run this, it's going to look like this. We will generate the code using O3 Mini. Then the code review comes back with a thumbs up, so we move on to executing the code. And here's what we see as the result. We can see a simulation of several hands of poker. And if we go into our directory here, we can actually see the code that was generated based on those requirements. Here's the code that was run. It looks like O3 Mini generated about 230 lines of code. And then we can see the output, which was saved to file as well. And if we want, we can see the review, but that was just a thumbs up here. All right, so that's one example. Let's look at another one, and then we'll look at how we built this. This was inspired by a guide written by Jess over at RZA.io. This is this huge data set of real estate appraisers in the state of California. They are all stored in an HTML table. I have saved this HTML table literally just by coming up here, File, Save Page As. I have saved it to my directory, and you can see that here it's stored as data.html. I am importing code-gen here again. I am saying in this file, there are a few HTML tables. We care about the second table, and I want to convert all the data in that table to JSON. And then I just call write, review, and run code, and I pass in not just the requirements, but an input file called data.html. This is what it looks like when that runs. We see our requirements. We generate code. We review the code, get a thumbs up again, and then we get back some JSON. And if we want to go look inside the results here, we can see now that we have a whole bunch of JSON here. Okay, so that's the finish line. Let's talk about how this thing works and how you could build this yourself. If you just think about what you do when you write code, first you might write the code based on requirements, then you might review the code, just skim through it, or maybe you'd have a friend review it or a coworker review it. Then maybe you get feedback on it and you need to revise the code, and you might stay in that process for a few iterations. Then eventually you're going to run the code, and sometimes the code works on the first try. It's always nice when that happens. Sometimes you run the code, you get an error, and you need to pass that error along and revise the code based on the feedback of that error, and then you go back and perhaps into a code review and repeat the cycle. And that's what we've tried to emulate here. There are 4 main blocks. We have write code, review code, run code, revise code. Now you could call this an agent. I would call this a workflow based on the definition proposed in Anthropic's Building Effective Agents post from back in December of 2024. The idea here is that we have these predefined code paths, these discrete modules, and in each case, we are really constraining the input and the output and the path that our program is going to take, which if you read that post, they would say this is one of the best ways to build effective agentic systems, which is whenever possible, use predefined workflows as opposed to these agents where the LLM is making the decision on what to do next to each branch. I'll show you how each of these modules work. I think each one is fairly straightforward. This is what write code looks like. We have a prompt, and we give O3 Mini some descriptions on how to act as an expert Python developer. We also want to be really clear that we only want code back. We don't want explanation. We are also passing in the requirements from the user. I have here a method to call OpenAI. This is just a very simple wrapper that's going to take in messages, instantiate a client, and then pass along the messages, use O3 Mini, and then give us back the response from O3 Mini. When I call the write code method, then I am just taking the requirements, constructing a list of messages, and then I'm calling OpenAI, and then I'm returning that code. So if I run this with a fairly simple example where I'm just going to ask it, what is 52 factorial? I will get code back that looks like this. Our second building block is called review code. When I started this project, I wasn't really sure if adding a review code method in here was going to actually add value. It seemed a little strange to use O3 Mini to review code that was just written by O3 Mini. but it actually does seem maybe about 20% of the time to catch either things that would cause errors or just improvements that I suspect significantly increase the odds of the code running successfully and accurately further down the road. And so here I'm just saying, you're a Python code reviewer, analyze the code for any errors, and I just tell it, hey, if the code looks good, respond with a thumbs up. Felt fun to use an emoji and a conditional here. And if not, then give me back feedback telling me what line number needs to be fixed. A simple example here would be that I define code, and this code is missing a single quotation mark, right? So a simple example of review code will look like this. And we get a feedback back that says the string literal is not terminated. It should have a closing quote at the end of hello world. So that is our second block, review code. Let's move on to run code. For run code, I'm using RZA.io to run this code that was generated by the LLM in a safe environment. So RZA gives you a sandbox environment where you can just pass in code and it will execute it for you and then give you back the result. You don't want to run code that's generated by an LLM, especially if that code was generated by a user directly in your production environment. You can imagine all sorts of bad things that could happen there if you basically give the internet a text box and say, tell it to give your LLM instructions, and then you're just going to run that, whatever that code spits out directly in your production environment. Bad things will happen there. So with RZA, you have a safe sandbox environment where you can take the code that's outputted from your LLM, run it, and then get the output of that. Also, you can set up custom runtimes. So with those custom runtimes, you can pre-install helper libraries that you want to use. So here I have my run code function. It takes in code as a parameter. I instantiate a RZA client, and you can get your RZA API key by going to RZA.io and creating an account, and then you'll find an API key on your dashboard. There are different options you can set up. So here I'm just saying that I want my runtime to be Python. If you do want to have Python libraries other than just the standard library available to you, you can pre-install those, create a custom runtime, and then you'll have to grab the revision ID of that runtime. Then you're going to pass in the code. And then if you want your code to be able to make HTTP requests, you need to pass along this HTTP allow, and then you can define the host that you want it to be able to access. Then we are going to run RZA client.command.execute, and we'll pass in these options and we'll get a result back. That result is going to have both the standard out of the execution and also an error code. So there's a few different cases that we need to handle here. One, there's just the possibility that for whatever reason, say we define our options wrong or something, that the actual API call itself throws an error, or the RZA helper library throws an error. We'll catch those here. But let's say that the API call works and we get back an exit code that is not 0. So typically this would be 1. That means that the RZA execution actually tossed an error, in which case the error will be stored in result.standard_error. And so in that case, we want to return that error message, but we will not return anything as a standard out. There are going to be times when the code does not throw an error, but it also does not return any standard out. This is typically going to be because the code generated by the LLM did not print the result of its execution out to standard out. That's a sort of common silent failure. And so we are going to catch that sort of silent failure and produce this message that we can pass back to the LLM to revise our code accordingly. And then there's the happy path. The happy path is just that our exit code is 0 and there is something stored in the standard out, in which case we will return that standard out. All right, so that's a lot, but generally speaking, the general high-level idea here is that we're passing code into the RZA client, we're running command.execute on it. If things go according to plan, we're going to get standard out. And if things do not go according to plan, we're going to get some sort of error message, which we're going to pass back to a revised code function, which we'll define in just a minute. And this is what this looks like in practice. If we have code of print hello world, and then we run this function of run code, then we'll see hello world. Or here's another example. Cool. So that is the general idea there. We can define arbitrary code as a string, and then we can pass that to run code. And let's just see what would happen here if we did not pass in valid code, and we'll get an error back. So that is the run code module. Let's say that either review code or run code did not go according to plan. We either did not get a thumbs up, but instead we got feedback, or we got an error message from run code. What do we do then? In that case, we want to revise the code. So for revised code, let's just look at what it might look like if we got feedback from the code review first, and then you can kind of imagine it's going to be basically the same thing with the error message, with the prompt slightly tweaked. But we have this revised prompt. It's going to say, hey, you previously wrote this code, but we did a code review and we got this feedback. Please update the code. And then we're also going to pass in that original write prompt just to make sure that when it does revise the code, it's still adhering to the same guidelines that we gave it initially to write code. We'll also pass in the requirements. And then again, we just have our function here to call OpenAI. We are going to create our prompt. We have our requirements to write a hello world program in Python. Let's just pretend that we got code back that was invalid, that was missing that single quote again. And then we had run the code review and we got feedback that said the code was not valid. And then we're going to get updated code and we're going to print that. And we get back updated code that has fixed the error by turning those single quotes into double quotes. And having the closed quotes there. I'm not going to step through it here, but you can imagine that if we got an error message, it would be the same. It's just that instead of feedback, we are passing in an error message. So there we have it. We've walked through the core building blocks. And what I love about this is each building block's pretty simple. Each building block, we're just basically passing a fairly simple prompt to O3 Mini. We're basically just taking the result of that, and then we're passing it along to the next building block. And then once we get to run code, we're basically just passing that script along to RZA to execute it in a safe place. And then based on the output of that, we're either then revising the code or we're just writing it out to output. Now, there are a few little niceties here that I'm going to change as I combine all of this together. I have this function called getPrompt. It takes a file name. So that then allows me in this prompts directory to store the prompts for each one of those modules that we previously talked about. So here's a little bit more fleshed out one for write code that not only has the language that we saw before, but also talks about the helper libraries that I have already pre-installed in my custom runtime with RZA. I also then have my prompt for review feedback. I also then have my review code prompt, which is the same as what you saw before. I have a prompt to revise code based on feedback. I have a prompt to revise code based on an error. So I really like this pattern of extracting out my prompts into text files. I also think it's really helpful to store the code in a file. And this way we're not trying to pass the code around in the context window from LLM call to LLM call. So I do have in a helpers file here at helpers.py some helper methods that just handle file IO. And the core function here is write code that will just take content and write out a timestamped file that contains the code. And I write that to a file called code for RZA, and then I append a timestamp to the end of that. It can be difficult to track down what's really happening if you're just keeping the code in the context window or just keeping it in memory and not actually writing it to file. So in helpers.py, then I have just some helper files to deal with writing the reviews or the output from RZA or the code to a file. And I like appending the timestamp so that if we are going through multiple iterations because of error messages or whatnot, I can see all the different versions of the code on that run. All right, so those are the big changes that I've made as I combined those simple building blocks together, is that I've just extracted out the prompts and then I'm writing the code and the output and the feedback to a file. Otherwise, this all should look pretty familiar. Revised code is taking feedback or error, and then it has a little bit of branching based on which one of those two it received, and this, loading the appropriate prompt. Review code looks pretty much the same, it's just we're reading the code from file at the beginning as opposed to passing it in as a parameter. Same with run code. We are loading the code in from file at the beginning. I have added here this concept of an input file name, and then down here, if that parameter has a value, then I update the options. and I set the new field of standard in on the options to whatever was stored in that parameter. So in the example I did up front, that was called data.html. So this is just a slight modification to the RZA execution that allows you to give it a fairly large amount of data to input. And then finally, we have write, review, and run code. And we can pass in here the requirements and the optional input file name. I will set a max attempts here. You will on occasion see it get stuck in a loop. And so you do want to set some sort of max attempts so it's just not going indefinitely. But then you'll just see all of these pieces glued together using some light conditionals in order to direct the workflow. All right, so here's what this looks like in action with a simple example. We just define requirements of calculate 52 factorial. We run that through write, review, and run code. And this is what it looks like. We print the requirements, we generate the code, we review the code, we get the thumbs up, and we execute the code with RZA. I have no idea if that number is actually correct or not, but it feels directionally accurate. All right, let's take a look at a much more complex example. And this is the one that we started off with, but hopefully it makes a little more sense now. Simulate a game of Texas Holdem. We run it through the same thing. All right, we have our requirements. We generate the code. I'm going to edit this out, but I'll just promise you that O3 mini is going to take a lot longer on this response than it does on the 52 factorial response because there is a lot more planning involved. So I will just say with O3 mini, you are oftentimes looking at 30 to 60 second delays. All right, and then we're going to review the code, get the thumbs up, and then we see the output. And then if we come in here and you look at the code that was generated, you can see how it has created this. And it's really cool to watch. I've run this now many times and I've gotten a different response every time in terms of the code that it was created. Actually, I think when I did the intro, it was about 280 lines or so, and here we ended up with a 320 some lines. So it's really, really cool as someone who's been writing code for most of my life to see this happen. Let me show you one more example that I think is really cool. There is a free API for the International Space Station location. And so you ping opennotify.org and it will give you back the lat and long of the current location of the ISS. And here I'm just going to say use the OpenNotify API to tell me the current location of the ISS. And I'm just giving it the URL, and I'm kind of making an assumption that it has baked into its knowledge here how to use that API. And again, when I set up my RZA custom runtime, I gave it access to the requests Python library, and I've allowed HTTP access on all hosts. So when I run this, I see the requirements, it generates code, we execute code, and we get the current coordinates of the International Space Station. And this is just amazing to me, all right? Like, we have basically just written an interface for a completely arbitrary API without giving any sort of instructions on how to use that API. It just sort of figured it out. And that is the sort of stuff that just blows my mind with what's possible with these code gen agents. So if you'd like more details on this, check out RZA.io, and would love to hear what you build with this.